Hello, my wonderful students. You're welcome to class again. Today we are going to continue from where we stopped the last time on mensuration. Okay, so don't forget the last time we looked at several questions on mensuration. We looked at finding area of a segment, area of a sector. Okay, so we are going to continue from there. So before we commence the class, please, I want you to get your writing materials ready. Okay, the class is going to be interactive as usual. So get your biro, your pen, your book, your calculator, your four-figure table, get everything ready. All right, and don't forget to invite your friends. Let them know that the class has started. Okay, so and don't forget, as you are joining this class, make sure you say hi, and don't forget to tap the like button. And if you are new on this channel, you are especially welcome to this class. This is where we solve mathematics, we make fun with mathematics. Please, if you love what we are doing here, don't forget to click on subscription button. And if you like this class, you like this video, ensure you tap the like button. Thank you very much. All right. Okay, so let's see how many of us are around. Once you just join, say hi. Let's see, so that we have good number before we commence the class. Yeah. Once you join the class, say hi. Hi to the class. So once you join the class, you say hi. Let's know the number of those that are in the class presently. Okay. All right. So as I join the class, say hi. Let's know the number of those that are in the class. Okay. All right. Now let's look at the problem on the board. So we are going to solve the problem together. Now the question says calculate without using tables or a calculator the area of metal plates required to make a circular waster whose interval radius is 2.2 meters and external radius is 7.8 meters. So now this is the diagram here. So how do you do this? Now you have to pay attention to the details in this question. Now the question says without using calculator or using tables. So you are not expected to use your four-figure table or your calculator. So if in your workings it is shown that you make use of calculator, all right, so you'll be penalized. So you may end up not getting anything. So let's pay attention to details. All right, now, so what do we want to get now? We want to find this area of the water which internal radius is 2.2 and external is 7.8. All right, what I just need to do, if I want to get that area, I'm going to say area of the external circle minus area of the internal circle. That gives me this area here, and that's what I want to get. All right, don't forget, this is just a concentric circles. So now, can we do that now? So area of the water now will be what? Area of the bigger circle. So that is pi r square, okay, minus area of this smaller. Okay, don't forget you are asked not to use calculator. So don't make use of calculator. So now let's see. Let's factor out pi. Can we factor out pi here? If we factor out pi, we have pi open bracket r square minus small r square. Okay, so the small r is going to be the radius of the smaller circle. That is 2.2 meters. While the bigger r, that is what 7.8 meters. Okay, so and that gives us pi. Now this is bigger r is 7.8 square minus a smaller one is 2.2 square. Okay, that gives me pi. That's now I'm going to be making use of difference of two squares because I'm told not to use calculator. So now look at it. If I have x squared minus y squared, now the result is x plus y times x minus y. Now this is difference of two squares, subtraction of two squares. So this is the result. So the same thing I'm going to do here. So this represents my x, while this y. So now this bracketed value turns to 7.8 minus 2.2 times 7.8 minus 2.2. Okay, do you understand that? So now let's evaluate. So we have this is 22/7. That's our pi. Now when you subtract 2.2 from 7.8, what do you have? You have 5.5. Okay, that's 5.5. Is that 5.5 or 5.6? That's 5.6. Okay. Now, the next one, now let's take away 2.2 from here. So we have 5. Okay. Now, this is supposed to be addition. Okay, sorry. This should be addition. This is subtraction. This addition. Okay, so we are adding. So when you add this together, what do you have? You have 10. You have 10. Okay. So now, can you evaluate this now and tell me the answer? So what will this one turn to? 22/7 times what? 56. Okay, can you tell me what is the answer? You know what to do? Drop your answer in the comment section. Let me see what you have for this. So everybody will be able to do this. All right, so that gives you are not making use of your calculator now. So, okay, 8 goes here, 7 goes here, 1, 7 goes here, that's 8. Okay, so now that gives you 22 times 8. And what will that give you? Now that's 6 and that's 7. Okay, that's 176 centimeter meter square. So that is the answer to the problem. Yes. Any observation, any question based on what you have done? So if you have any question, any observation based on what you have done, please kindly drop your question, your observation in the comment section. Let's see what you have. Okay. All right. Toyosi, you are welcome to class. We are others. Okay. Jai Fish, you are welcome to class. What of others? Others should say hi. Let's see those of us that are in the class. All right. So that is the answer to that problem. All right. So can we move down to another question here? Let's move down to another question. All right. That is another question. The WAEC past question. Okay, so now let's look at the question. Now, a doorway is made up of an arc ABC. The doorway is made up of an arc ABC, which is a quarter of a circle of radius 2 meters. Do you understand that? So that means this is a quarter. What we have here is taken from a circle. All right, which radius is 2 meters. Okay, so this should be I think this should be in centimeter, not, no, if this is a meter, I think this is a meter as well. All right, so we have it in meters here. Okay, so they're supposed to be meter. Okay, so two uprights CD and AE. Two uprights. We have two uprights CD and AE. 3 centimeter each. So, and a horizontal base DE. So we have an horizontal base DE. The dimension of the horizontal base is not given. Now, what does the question want us to do? The question wants us to show that the perimeter of the figure is pi plus 6 plus 2 square root of 2. So how do we go about this question? Now let's see, how do we go about this question? All right, so now let's look at the question. Now, the first thing I need to know, or that is given in the question, that this is an arc. ABC is an arc. All right, is 1/4 of a complete circle. So that's what the question says. Now this is quarter of a circle. So that means the perimeter will also be a quarter of the whole circumference of the circle. All right, so the question wants me to get the perimeter of, show that the perimeter of the figure is pi plus 6 plus 2 square root of 2. Now, what I need to get now, I want to get this plus this plus this plus this. Now, in this diagram, I have the two sides here given. I know that. So I need to get this curve, the length of this curve, and the length DE. And don't forget, length DE is also the same thing as length CE. All right. So, and note that length CA is a chord of a complete circle. Do you understand now? Is a chord. So now why don't we just get this length of this chord, which is going to be equal to this? So I will say chord AC is 2r sine theta. Okay, so this is the formula for chord. Oh, sorry, over 2. Okay, so that's what we have, over 2. So now I have the radius, that's 2 meters, and also I have the angle. What is the angle subtended by this chord? That's 90. So let me just plug that in so that I'm able to get this length AC. So that gives me what? 2 times 2 sine 90 over 2. Okay, do you get that now? And that gives me 4 now sine 45 degrees. And that's the same thing as 4 sine. Now, what is sine 45 degrees? Can anyone tell me what is sine? It's a special angle, sine 45 degrees. So you must understand all these special angles. You must know them by heart. You can see now. So you are being tested of special angle. So what is sine 45 degrees? So if you know the answer, please drop that in the comment section. That is square root of 2 over 2. Okay, square root of 2 over 2. All right. So now we now have this DE. DE is the same thing as CA or AC. So we have DC, DE, which is equals to AC is what? 2 goes there 1, 2 goes there 2. That's going to give you 2 square root of 2. Okay? So, and that's going to be in meters. All right. So we have already gotten this. So we need the curve here. So what is the curve? That's the last thing we want to get. Now, this is 1/4. 1/4 of the whole circumference of a circle. So I'll just say, okay, arc ABC equals to 1/4 of 2 pi r of 2 pi r. You know, this is the formula for calculating the circumference of a circle, 2 pi r. So 1/4 of it is what we have here. So we can say 2 goes here 2, 2 goes here what? 1. All right. So now don't forget this, your r is what? Is 2. Okay, so you can just add this one as pi times 2 over 2. Do you understand that? So now 2 cancel 2. So we have your arc to be equals to pi. So that's it. That is going to be in meters as well. So that means length of arc is what? Pi. Because the length of this arc is 1/4. 1/4 of the whole circumference of a circle. That's why I said 1/4 of 2 pi r. This is circumference of a circle. All right. So 2 goes here 2, 2 goes here 1. So we have 2 lengths. R is 2. So 2 we cancel that 2. So we have pi lengths. Now, so we have all what we need now. So we are adding this plus this plus this plus this. So you will see when you add everything together, what are we going to have? So let's first add these two sides together. We have 3 plus 3 plus this curve. That's the arc. That's plus pi plus this one. What do we have for this? That's your DE. Your DE is 2 square root of 2. That's 2 square root of 2. So you can see now the answer now is pi plus 6 plus 2 square root of 2. So that gives what we have. Yes, I want to believe you all get that now. So now before I move on to the next thing, any observation? Do we understand that? Okay, let's see. Any question based on what you have done? You can drop your thoughts based on what you are doing. Yes. Okay, the board is not fully okay. I think it's okay this way. All right. Can we see the whole screen now? Can we see everything? All right. I need a response. So can we all see the screen now? I think by now it should capture everything. Okay, can we see this board? Can we see the whole board? All right, okay, thank you, Divine Huber. Thank you. Thank you. Okay, so that means we can move on to the next part. Okay, so now let's look at this. The second part of the question. Now the question says you have to find the area of the figure in terms of square root of 2 and pi. Square root of 2 and pi. So how do you do that? We want to find the total area here. All right, don't forget the dimension here. This one is 2 square root of 2, and that is in meters. Okay, so I can find this rectangle. I can find the area of this. Now what I need to get now is the area of this sector here. So I'll segment rather this area here. So I need to get, so since I can get this one easily, so now let me get this shaded region. So that is area of the segment. Now, to get area of segment, you remember the formula, that is going to be area of sector minus area of triangle. Area of sector minus area of triangle. All right, there is one interesting thing about this question. This question is, it has made the work easier for me. So area of sector here, I don't need to begin to use theta over 360 times 2 pi r. No, since the question says that this sector that I have here is 1/4 of the whole circle. So I'll just say, okay, now area of segments, which we are looking for, is equals to area of sector. Area of sector is 1/4 of area of circle. What's the formula for area of circle? That's pi r squared. Okay, so now that's pi r squared. So now this gives me the area of the whole sector here. You can see sector AOC. All right. So now, out of this sector now, let me take away this triangle. I'm taking away this triangle so that I'll be left with the segments. So minus 1/2 r squared sine theta. This is the formula for area of triangle. Okay. So now we can go ahead and plug in the value. All right. So now let's see, what do we have here? So now this is 1/4 times 22/7 times the radius is 2. So we have 2 times 2 minus 1/2 times 2 sine 90. You know the angle subtended is 90. All right. So, okay. So here, now let's try and simplify. Say 2 goes here 2, 2 goes here 1, 2 goes here 2, 1, 2 goes here 1. Okay, so at this side we have your pi. So don't forget, we are not supposed to use 22/7. We are supposed to leave it in terms of pi. So let's write it in pi. So this should be an error. So because the question says your answer should be in terms of pi. So that means we have pi here. So let's clean this and just write pi. Okay, that's pi. All right, minus. Now these 2 cancel these 2. Now don't forget, sine 90 is what? 1. Sine 90 is 1. So that 1 multiplied by 2, we have 2. But we have a negative, so that's going to be minus 2. Now this is in centimeter. Okay. All right. So now what we have here now is in is in centimeter. Okay, centimeter square. That is the area of the segment. This segment here. Okay, so that's going to be pi minus 2. So this is pi minus 2. Now, let us now get the area of this rectangle. So we now add it to this. That gives us the total area of the figure. All right, so now what's going to be the area of this? Okay, can you tell me what's going to be the area of this? So do that and drop your answer in the comment section. The area of this rectangle. Area of this rectangle. Okay, so do that and let me have your answer in the comment section. Yes, area of the rectangle. Anyone? Once you have the answer, you drop it in the comment section. Area of that rectangle is very simple. It should not take you up to 10 seconds before you get your answer. So area of the rectangle is what? Yes, anybody? Area of the rectangle. Okay, yes, Uba, I can see your answer. That's c square root of 2. C square root of 2. Yes, is anybody dropping an answer? Every one of us should be able to do that if you have an answer. Okay, so area of the rectangle. Yes, Uba, thank you for that. Any other person? Yes, is Toyosi giving us answer? Who is also there? Yes, low casting, are you giving us answer? Foundry, visible, are you giving us answer? Okay, so you just drop your answer in the comment section. So, all right, make sure you are doing something. Okay, all right, make sure you are doing something. Okay, so I think what Huber gave is correct. Now let's see. Now this is a rectangle. The formula for area of rectangle is length times breadth. Okay, and that's going to give us the length in this case here is what? That is let's say 3 times 2 square root of 2. Okay, and then that gives us what? That gives us what? 6 square root of 2 in centimeter square. Okay, so now, so what's going to be the total area? The total area, that's what the question is asking for. What's going to be the total area of the figure? So we had this and this together. So we have pi minus 2 plus 6 square root of 2. Okay, everything is going to be in, sorry, not in centimeter square, it's going to be in meters because our dimension is in meter. Let's pay attention to what we have here. So it's going to be in meters. All right, so now this is going to be the answer to the problem. So we have pi minus 2 plus 6 square root of 2. Yes. Any question based on what we have just done before we move down to another interesting question? Any question based on what we have done? Any observation, any question? Okay, if there's no question, so we can proceed to the next thing I have here for you. Okay, shows a quadrant of a circle of radius r centimeter drawn within a square of side 10 centimeter. Now, as you can see, now if the area of the quadrant is half of the area of the square, now find the value of r correct to two significant figure. Yes. Now, before I solve this problem, I must understand what the question is saying and what the question is asking for. Now, the question is talking about a quadrant. I must know what a quadrant is. Now, if you have a circle of this form and I divide it into 4 parts. Now, this first part now is a quadrant. This is a quadrant. We call this first quadrant. This is second quadrant, third quadrant, fourth quadrant. So now the angle in a quadrant is 90 degrees, right? So that will help me now to answer this question. Okay, so we now know what a quadrant is. So once you know that, you should not have much problem. All right. So now in that case, if that is a quadrant, you understand what a quadrant is. That means that this fraction of side of the square is going to be the radius of the circle from which this is cut out from. And that means that this is going to be 1/4 of the circle from which this sector is gotten from. You understand now? Since in a quadrant we have 90, as you can see, it's even 90 here. You can see that. So, and we have 4 90s in a circle. So now it's going to be 1/4 of the total area of a circle. So I hope you understand that. Now the second thing is a square. One of the property of the square is that all the sides are equal. So that means this a side is given here. This is also 10 centimeter, this 10 centimeter, 10 centimeter. Okay, so now since we understand that, then now let us now write area of this quadrant. So area of quadrant is equals to half of area of the square. Area of the square. And that's what the question is talking about. Can you see? Now, if the area of the quadrant is half of the area of the square, so this is where I need to pay attention to. Okay, so now let us now write out the formula for area of a quadrant. Area of a quadrant, that is, since it is 1/4 of area of a circle, so I will just write 1/4 of pi r squared. That is the same thing as area of a quadrant. Do you understand that? And that gives you 1/2 of area of a square. So area of a square That is length times length. The sides are equal. All right, so from here now, we can plug in the values. We have 1 over 4 times 22 over 7 times r squared. I'm actually looking for r equals to 1 over 2 times what? 10 times 10. Because the side of the square is 10. Okay, so now let's simplify. 2 goes here, 2 goes here, 11. All right, so 2 goes here is 1, 2 goes here is what? Is 5. So we have 11r squared over 7 equals to 5 times, that's going to be 50. Okay, so what do we do next? We cross multiply. So we have 11r squared equals to 50 times 7. And that's 11r squared equals to 3 what? 350. Okay, so now what do we have? We divide both sides by what? By 11. So when you divide both sides by 11, so let's see, we have r squared equals to 350 over 11. So r squared, r will be square root of 350 over 11. Okay, so now don't forget the question asks us to correct to the nearest 2 SF. So so you can divide that 250 divided by 11. So what do we have? We have 31.81. So that's r equals to square root of 31.8181 and so on. So therefore r, which is the radius, let's find the square root of the answer now. So that is 5.640 or 641 centimeter. Okay, this centimeter or meter, so it's going to be in meter. Okay, so now what do we do next? Now the next thing is we correct our answer to 2SF, 2SF, 2 significant figure. So this is the first significant figure and this is the second significant figure. So you count 1, 2. So we have 5.6 meters. So 2SF. So okay, I hope it's in as meters. Okay, I think it's in centimeters. So that means this is supposed to be in centimeter. Okay, use centimeter. So this is centimeter. So you have to pay attention to the units. Very, very important. So that's the answer to the problem. All right. So any question based on what we just did now before we move down to the next thing. Yes, you can drop your question, your thoughts based on what you have done in the comment section. Let's see. What's your view about what we just did now? Okay. Okay. So let's move on. Okay, this is another question. Okay, so can I give you 2 minutes to view the question, and let's see what you can do about this question. So can we try this question and see before we solve the problem together? Yes. So try the question. Once you have an answer, you can drop in the comment section. Let's see what you have. So in the figure, line XY is an arc of a circle, and Z in that diagram, okay, Z in that diagram is not the center of the circle. So the Z is here. Z is not the center of the circle. If you know the implication of that, that means that you cannot call this a sector. That is the meaning of that. Z is not the center of the circle. So it means this is not the radius. That's the implication. Now, length XY is 100 centimeter. Length XZ is ZY, which is 120 centimeter. So now you have to calculate the what? The radius of the circle. So the radius has not been given, so you calculate the radius. Now after that, you calculate the area of the segmental curve. Now this segmental curve. So two significant figures. And the last one, the total area of the design to three significant figures, right? So this is a wire question. Okay, so let's see what you can do within 2 minutes before we solve the problem together. Make sure you make an attempt. That is the best way to improve in mathematics. So once you see question, rack your brain on it and see what you can bring out. So even if you don't get the answer, that move is a way of improving. All right, so let's see what you're going to have. Okay, is there anybody with the answer? Anybody with the answer to that problem? Anyone? All right, so if nobody is dropping an answer, I think we can go ahead and solve the problem together. Okay, but if you are still on it, okay, you can just cross-check with what you have over there. So, but this question requires a lot of attention. You need to reason very well to be able to get this question. So, I want you to pay attention to how I'm going to approach the problem. All right, so now let's look at what we have here. Now, in the figure, xy is an arc of the circle, z is not the center of the circle, so we have this. So we have length xy is 100 centimeter, xz equals to zy equals to 120 centimeter. You have to calculate the radius of the circle. So that's the first task I want to do. I want to get the radius of the circle from which we have this arc. Okay, so now see, let me draw the diagram again. I'm going to draw the diagram again. It's like this. So we have a chord. This is a chord. That's called XY. Can you see that now? All right. So now, don't forget, I have a line here, which is 10 centimeter. You see, I'm going to draw this line down such that it will go to the center of the circle. Now, let me bring it down now. Down. Let's assume this is the center of the circle. So if this is the center O of the circle, so we can have a radius, which we're actually looking for, and this as well. Okay. And these sides, they are inside. These ones, we have this. These are the 120, okay, 100. Okay, so now this line is drawn such that it's perpendicular to this chord. Is perpendicular to this chord. So if a line is drawn from the circumference of the circle such that it's perpendicular to a chord, or a line from the center of the circle, okay, that's the way it's supposed to be, from the center of the circle such that it's perpendicular to the chord. If it is perpendicular, now don't forget the theorem I said in the last video. So if you have not watched my last video, make sure you go through the videos I've made on this. Now, this side here will be equal to this side here. That is, let's assume that this one is m. Now, xm will be equal to my. If this line is perpendicular to the chord. Do you understand that? Okay, so if you get that, so it's going to be. So now, in this case now, all right, so what I will do now, this is the radius, this is r, and this is also a radius. Now, if I want to get this small portion here, this small portion from here to here, what is it going to be now? You know, from here, let me call this place P. If I call this P, OP is also the radius. All right. Now, OM is 10. So if I want to get MO, it's going to be OP minus PM. And so that's going to be what? So from here to here now, it's going to be R minus 10. I hope you understand that. Okay, let me write it well so that let's ignore this one for now. Let's ignore that. So this side here is R minus 10. Okay, since from here to here is R, so this place is 10. So to get this small part is going to be R minus 10. Okay, you understand that? This is R because this is the line from the center of the circle to the circumference of the circle. So this R. And don't forget, just like I said, this line is drawn such that it's perpendicular to this chord. So the meaning is that this side here will be equal to this side. Don't forget, xy is 100. So this is going to be half of 100, and that's what? 50. So we have 50 here, 50 centimeter. So we can now look at this triangle in triangle OMY. Triangle OMY. Look at this triangle OMY now. So we have this to be sides of right angle. We have 50 centimeter and R minus 10 centimeter. Okay, and the hypotenuse is R. So we are going to be making use of Pythagoras theorem here. You understand? So we have 50 square plus R minus 10 square. It will give us R square. So that's what we're going to have. Square of the two sides. Okay, when you add them together, it will give you the square of the hypotenuse. So now, so this one gives you what? This one gives you what? 2,500. Now you can expand this one. If you expand this, you are going to have R square minus 20R plus 100 equals to R square. How did I get this one? Every one of you should be able to do that. So look at it. We have R minus 10 times R minus 10. Now let's expand. This multiplies this. It also multiplies this. Okay, that's the first thing. So we have R times R, we have R squared. R times 10, we have negative 10R. So this multiplies this and also multiplies this. So negative 10 times R, that's negative 10R. And negative 10 times negative 10, that's plus 100. Now when you look at this and this are similar. So I have R squared minus 20R plus 100. Can you see now we now have this? So that's how to expand that. Okay? So now, what do we do next? Now, I'm going to move everything here to this side, leaving negative 20R at the left-hand side. Now, can we do that together now? So we have negative 20R equals to, we have R squared. I'm moving this one first, negative R squared. Now, let me move this. I have negative 2,500. I'm moving this one, negative 100. Okay. So I have negative 20R. Now this negative R squared minus negative R squared. That R squared minus negative R squared, sorry, that gives you 0. This cancel out. So now this and this gives you what? Equals to negative 2,600. So negative 2,500 minus 100, that gives you negative 2,600. So you divide both sides by 20. So you have R equals to negative 2,600 over negative 20. Okay, this cancel this. Now, negative cancel negative. 2 goes here, 1. 2 goes here is 130. So R equals to 130 centimeter. So the radius of this circle is 130 centimeters. So now let's write that here. R is 130 centimeter. Okay, so we have solved the first part of the question. Now, the second part of the question is to calculate the area of the segmental curve. We want to get the area of this region here. This is where we want to get now. So how do we get that? Now, to get that, area of segment is area of sector minus area of triangle. You understand that? Out of the whole sector I have it, this is a sector. This is not a sector. This is a sector here because we have radius. All right. Out of this sector here, take away this triangle. That gives us area of the segment. So that's what we're going to do now. So, and don't forget, our radius is what? Is 130 centimeter. Okay, so I have area of segments. Now, that is area of sector. Area of sector, that's 1 over, area of sector, that's theta over 360 times pi r square minus area of triangle, that's 1 over 2 r square sine theta. Okay, do you remember this formula? Okay, so this is the formula I'm going to use. So now let's plug in the values. We already have r, okay, but then we have an issue now. How do we get the angle subtended? So that means we need to get that angle, because if we don't have this angle now, we'll not be able to get it. So now let's get this angle here. So we'll now come back to this formula. So now how do we get this? We are going to be making use of length of a chord. Length of a chord. So we have this. Now we have r equals to 2r sine theta over 2. This is the formula for length of a chord. Length of a chord L equals to 2r sine theta over 2. Now our chord in this case now is x, y. So we want to get that, and we already have a chord. Do we know what a chord is now? Okay, so what is our chord? Our chord is 100. You understand now? So we have 100 equals to 2 times r. R is 130. We have that here. 130 sine theta over 2. You get that? So now you divide both sides by 2 times 130. So we have 100 over 2 times 130 equals to sine theta over 2. Okay? Are you flowing? All right. So let's clean the diagram here. So here we have 100 over 260, 100 over 260, okay, equals to sine theta over 2. All right, so that's what we have, and this can cancel this. 2 goes here is 5, 2 goes here is 13. So we have 5 over 13, okay, equals to sine theta over 2. So we can find arc sine of both sides. So let's find that. We have arc sine of 5 over 13 equals to theta over 2. So let me multiply 2 by both sides. So if I multiply this one by 2, you have only theta here, because 2 is surely cancel 2. Cancel 2 here. So multiply this by 2. We have 2 sine. Now, what is 5 divided by 13? So 5 over 13 is what? Okay, that's 0.6846. So that's what you have for that. Okay, so now we now have 2 times. Now let us find arc sine of 0.3846. Arc sine of 0.3846. Okay, so if you have your answer, you can drop that in the comment section. Let's see. So make sure you are doing something. So punch your calculator and press arc sine of 0.3846. Drop your answer in the comment section. Let's see what you have for that. Yes, is anybody dropping the answer?